Okay, quadratic equations, nature of roots, sum and product of roots, higher order equations, and circles. All right, discriminant. First of all, if b squared minus 4ac, which is the discriminant, is less than 0, then I have imaginary roots. Imaginary. All right, and what would that look like if I was going to graph that? That would be a parabola that doesn't intersect the x-axis. It would look like one of those two. All right, if b squared minus 4ac equals 0, then I have real, rational, and equal roots. All right, and this is the case where I have one root. All right, if they're equal to each other, then there's one distinct root. And what this looks like is it comes down and it just is tangent to the x-axis. It hits it at exactly one point like that. Okay. If it's b squared minus 4ac and it's greater than 0 and it's a perfect square, well, if it's a perfect square, the square root of a perfect square is going to be rational. So I have real, rational, and I have two different roots. I have unequal roots. All right, real, rational, and unequal, and that gives me two roots. And that's going to either look like that or, like that. All right, it's going to cross in two places. And then b squared minus 4ac greater than 0 and not a perfect square, then it's real, irrational, and unequal. All right, because then you're going to have like something like the square root of 5 or the square root of 7. You're going to do plus or minus the square root of 7. So that gives you an irrational number. And that really doesn't look any different than when I have two real rational roots when you look at the graph. Okay? Solving quadratics. You can factor, use the quadratic formula, use completing the square, or you can use incomplete quadratics. Now these other ones I've kind of covered in other videos, right? So this incomplete quadratics, I want to isolate the square and then square root both sides. Don't forget the plus or minus, right? So if I have y minus 4 squared equals 48, then I take the square root of both sides because the square is already isolated, and then I get y minus 4 equals plus or minus, and then the square root of 48 is 4 radical 3, and then I move that 4 over, so I get 4 plus or minus 4 radical 3. Just like that. Okay, next, sum and product of roots. The sum and product of roots is not given to you on the formula sheet, so you kind of need to memorize that. The sum is negative b over a, and the product is c over a. How's this usually applied? Well, sometimes they'll just ask you, what's the sum and product of the roots of this equation, and they'll give you the equation. However, more frequently you'll see something like this, 2x squared plus 4x plus k equals 0, and one of the roots is negative 4. Okay, so I know that a is 2, b is 4, c is k. I also know, we'll say R1 is negative 4. All right, so I'm going to start out with the sum because I've got b and a. So I know R1 plus R2 has to equal negative b over a. So negative 4 plus R2 equals negative 4 over 2. That's going to give me a negative 2. All right, so I'm going to get, add 4 to both sides, I get the second root is 2. All right, now once I know both roots, then I know R1 times R2 has to equal c over a. Okay, so in this case, that's going to give me negative 4 times 2. Negative 4 times 2 has to equal k over 2. So negative 8 equals k over 2, and negative 16 equals k. Negative 16 equals k, and I found the value of k. All right, higher order polynomials, I touched on this earlier in the video, and this multiplicity of roots, we're just not going to really talk about that. That really has never come up. It's there for you if you want to look at it. I don't know, it's kind of an interesting topic. For trinomials and binomials, I'm going to let x squared equal a. Well, the first thing I'm always supposed to do is look for a GCF. So I have x, and then I have x to the 4th plus 3x squared minus 10 equals 0. All right, and I already have one of my answers here, x equals 0. That's one of my answers. I'm done with that x. Okay, so I have one answer there. Now, if I let x squared equal a, I can rewrite this part in the parentheses as a squared plus 3a minus 10 equals 0. And then hopefully that'll factor. If it doesn't, I have to use the quadratic formula. All right, let's see. Multiplies to give me negative 10 and adds to give me 3. So plus 5 minus 2. All right, so I'm going to get a equals negative 5 and a equals 2. But x squared is a, so x is going to equal plus or minus I radical 5, and x equals plus or minus radical 2. So I have 1, 2, 3, 4, 5 answers, and it was x to the 5th for the largest exponent. When you have 4-term polynomials, 1, 2, 3, 4, 4-term polynomials, I need to factor by regrouping this. So I'm going to group it. X cubed plus 3x squared plus, and then 5x plus 15, and then a equals 0. And then I'm going to take the GCF out of each group. So I have x squared n times x plus 3. And for this one I have 5, and then I have x plus 3. And you can see that the common factor for each one of these terms is the binomial x plus 3. So I know x plus 3 times x squared plus 5 has to equal 0. Then I set each one equal to 0. So x plus 3 equals 0. I get x equals negative 3. Okay? That's my first answer. All right? For the second one, I know x squared plus 5 equals 0. Well, here's an incomplete quadratic. It doesn't have an x term. So I know that x squared has to equal negative 5. And then in order to solve that, I take the square root of both sides. So it's plus or minus I radical 5. So 1, 2, 3 answers. And 3 was my largest exponent. Yeah, 1, 2, 3 answers, and 3 was my largest exponent. Solving systems with the calculator. All right, so if you're given a system of equations, even if it says algebraically, I'll say you can't figure out how to do it algebraically. You just had a brain fart. You can't figure it out. You can always solve both equations for y and plug them into the calculator. And if it doesn't specify algebraically, then this is a full credit solution. 10 minus 4x for y, and the other y is x squared minus 3x plus 5. Now you could pretty easily set those equal to each other and solve, and you don't necessarily have to resort to this. But I can go in here to my y equals, all right, and put in 10 minus 4x for y1, and for y2, I can put in x squared minus 3x plus 5. Oops, I missed my plus sign. Plus 5. There we go. All right, and then just try like a zoom 6 right on the standard window setting. See if you can see where they cross. Okay, and there we go. All right, here we got it. All right. I am getting answers of, I find the answer, I suspect that maybe it might intersect up here a little bit further, right? So I may want to kind of expand my window a little bit. So I can do that through my window, and I need a larger y value. I need my y max to be bigger. So I'll try like something like, oh, I don't know, we'll try 50 first, right? And then graph it and see what it looks like. Maybe you can see, aha, it does in fact cross twice, right? So you want to kind of zoom out on this if you're resorting to this, and zoom out and see if you can't find it where it'll hit again. This is under second calc, the intersect, all right? And then I'm going to move it closer to this first intersection, just get it in the neighborhood, and then hit enter 3 times. And the calculator will compute the intersection for you. So, you know, my first solution is negative 2.8, right? So I've got like negative 2.8, comma, 21.2. And you round it to whatever place, you know, it wants it to. To find the other intersection, it's very similar. It's the same procedure. Just make sure you move the spider guy, you move the cursor closer to that intersection, and that's close enough. Hit enter 3 times. Make sure that it jumps to the intersection you want, all right? And then go from there. So then my other solution is 1.8, comma, 2.8. There we go. That's how you can use the calculator to graph. By the way, to receive full credit for a graphic solution here, I need to draw my picture, right? And kind of, there we go. And this one was y1, this one was y2. So I'll label that one y1 and that one y2. And the last thing I need is my window settings. It was negative 10 to 10. And the y was negative 10 to 50, I believe, is what I set that window at. And there you go. Okay? There is full credit. Okay, quadratic word problems. All right, it's important to remember that the axis of symmetry is negative b over 2a. If you're graphing on graph, use the table. X-intercept is the roots, is the solution. So the height h and v, ball reach when thrown in the air, is function of time, as a function of time t in seconds, is given by this equation. This does not mean h times t. This h of t, that's the height, okay? Don't let that throw you off. You don't have to put like h times t in there, all right? It's h of t, all right? Find in the nearest tenth the maximum height the ball will reach. So the time it will take for it to reach its maximum height is going to equal negative b over 2a. That happens at the axis of symmetry because basically the ball's going up and coming back down. And it's going to be right here, right? This is the negative b over 2a. So that's going to be negative 30 over negative 32, okay, which is positive 15/16. All right, 15/16 of a second. All right, and now I need to find in the nearest tenth the maximum height the ball will reach, and I can do that by evaluating that expression for 15/16. All right, so it's going to be negative 16 times 15/16 squared plus 30 times 15/16 and then plus 6. And 20.0625, that's the maximum height. 20.0625. And that comes from evaluating h of 15/16. Okay? All right. Next, solving equations with the calculator. Yeah, you can let y1 equal one side and y2 equal the other. All right? When you're doing this, you have to be careful, all right, to make sure that you're seeing, exactly where things cross. All right? You're going to let the left side be y1 and the right side be y2. All right? And then you're going to graph both and calculate the intersections. You may have to zoom out to find all of the solutions. I think that's what that careful of image is talking to. Okay, moving on. All right. No, I think I'll just do circles in the next video. We'll finish this one. Okay. So y equals clear, clear. Whoops. What did I do? There we go, clear. All right, good. All right, so we let y1 be 5x squared minus x plus 5, and we let y2 be 2x plus 4. Just like that. And then we hit just start with the standard window first. Hopefully we'll see a parabola and see it cross twice. All right, what do I got here? Well, it almost looks like they don't even cross, doesn't it? Okay, so what I need to do here is zoom in on that just to kind of get a better look at it. So I'll go to zoom, and I'll go in, zoom in, and see it's got a little dot there? I can move my cursor up because I really want to zoom into about where I think they cross and hit enter, and I can zoom in and see that in fact they do not cross. So I can't use this technique with the graph, okay? So what I have to do here is solve this algebraically, all right? So it'll be 5x squared minus 3x plus 1 equals 0. All right, and you can either try to factor that. Obviously, if you have imaginary solutions, it's not going to factor. All right, this is a good case for completing the square. All right, so we'll run through not completing the square. I don't like completing a square here because I'd have to divide by 5. I meant to say quadratic formula. Okay, so it's going to be negative b, which works out to 1, plus or minus b squared, which is 1, minus 4 times a times c. So 4 times 5 is 20, times 5 is 100. All over, oh, I'm sorry. I started using the wrong numbers. Start over. All right. It's b squared, which is 9, plus or minus, it's negative b, oh my goodness. Negative b, which is 3, plus or minus the square root of b squared, which is 9, minus 4 times a times c, which is going to be minus 20, all over 2 times a, which is 10. All right, and then when you simplify that, you'll see it's imaginary. Okay, we'll do circles in the next video. Thanks.